a continuum with limits at infinity, the first thing you want to do, we can see as we're approaching infinity, we want to divide the numerator and denominator by the highest power of x in the denominator. So divide all of the terms by x squared, simplify that, substitute in your values for infinity, and then solve. Evaluate the limit. Okay, so we've determined this was the highest power. We divided all the terms by x squared, simplify, this is what we were left with. Then afterwards we substitute in infinities everywhere that there's an x, and then infinity squared, infinity, infinity squared, which is just infinity. So then a number divided by infinity is 0. So we would just be left with 3 halves. Okay, here's your next example. Go ahead and write it down and divide everything through by what? What's the highest power in our denominator? X squared. So divide everything through by x squared and simplify, and then substitute. Okay, so when we simplify, we get 2x minus 3, 1 plus x squared, 1 plus 2 over x plus 4 over x squared. Now when we substitute infinity, and this one's a little bit different, we would have 2 times infinity, which is just infinity. We bring down negative 3 or minus 3, and then we have a number divided by infinity, which is just 0. Then we have 1, 0, 0. Infinity minus 3, infinity minus anything is just still going to be infinity. Divided by 1 is infinity, which we know does not exist. Okay, we'll just look at one more so you see an example of all the different solutions you can get as in positive infinity, negative infinity, or exact value. But this is like after it's been divided through with the power. This time if we want to evaluate it at negative infinity, first of all, when we substitute those in, you're just going to have 2 times negative infinity minus 3 plus 1 over negative infinity. A number over infinity is just going to be 0. Right? So then we would have 1 plus 2 over infinity, which technically you don't have a negative infinity right there. It's just going to be a 0. That just simplifies to 0. And then we what? Have 4 over negative infinity. We're just going to have a number over an infinity is 0 again. So what happens if you have 2 times a negative infinity? What do you think? It's going to be a negative infinity, right? Minus 3 and then plus 0. 1 plus, then we get 0 and 0. So a negative number, a negative, very large negative number minus a negative number is just going to give us what? A negative infinity, which does not exist. So we've seen one with positive, we've seen one with negative. Now let's look at some trig functions next. Okay, so the first thing we want to do is we're given this limit. This time we have a trig function. Our f of x involves some trig, and as x approaches 0, so we like to attempt direct substitution anytime we can. That would give me cosine of 0, which is 1. 1 minus 1 is 0. 0 times 3 is 0. Over 0, we would get indeterminate form, so we're going to have to do something. Usually we factor, usually we would try to rationalize, we would try some different things, but in this case the only other things that we've been given prior that we can do is we have some properties. And so one of our properties, if we break this apart using our properties, I could say I can pull this constant out, the 3, as x approaches 0, and multiply that by, see if I can isolate the trig function to the right. 1 minus cosine of x. Okay, so properties to be able to pull this out. So if we evaluate this limit, what is the limit of this? Just 3. Good. Now plug in a 0 over there. What's 1 minus 0? 0 over 0. We're just going to have 0 there. We can evaluate that, and then so you can just do 3 times 0 is going to be 0. Okay, so if we have our limit of cosine theta, tangent theta divided by theta, um, is there anything we can do to simplify our trig function a little bit? Anything on the trig side of things? Can we rewrite this in any kind of way? Yeah, and I'll show this each step out. So cosine theta, there's not much more I'm going to do right now, but how can I rewrite tangent theta? Sine of theta over cosine of theta. Good. And then let me just leave this over theta. Well, what happens there? Good. We have our cosines that we can cancel. And then we'll have, what we're going to be left with is sine of theta over theta as theta approaches 0. I want you to look at that for a minute. Okay. If I told you it is equal to 1, think back to a previous lesson and see if you can make that connection. A property that we had given you. Remember when we looked back and we recall that the limit of sine x over x as x approaches 0 is equal to 1 by the squeeze theorem? Okay. We want to be able to use that property. You see, in this case, what's the difference? What is our x in this particular case? Just theta. Yeah, so we could see that. Okay, so we jot this one down. The limit of sine of 3x divided by 4x as x approaches 0. In our mind, we always try to do direct substitution. We're aware that this is a trig function, and I also know that I'm wanting to look to see if things match this property as well. And in this case, we could see that the x terms are not the same, so I really can't do that right now. I can use some of the other properties that were given in our theorems, so we want to try to simplify this a little bit. I'm going to have 1/4. I can pull there's a known 1 there, so if you see that, I can pull 1/4 out. Because the issue is that these are not the same, right? So I'm going to try to manipulate this, and sometimes it's a guess and check, but I'm going to pull a 1/4 out. I'll give you some ideas of some things you can do. And then I have the limit that's the limit of sine of 3x over x as x approaches 0. Okay, so that's what's left. Well, that took care of the 4. That makes me feel a little bit better. But I either need to do something about that 3, or I need to do something. This term needs to match this term, just like theta, sine of theta over theta, sine of x over x. So, suggestions? What can I multiply this by? 3, right? But if I do that, I have to also do the same thing to the top, right? So I could just take this term and multiply by 3. Whatever you do in the denominator, do in the numerator. So I'm bringing down this 1/4. I'm just bringing it down. And then times 3 sine of 3x over 3x as x approaches 0. Alright, well that's looking a little bit better, but now what's the problem? The 3 to the right over here, but what can we do about it? Yeah, we have a property that says we could just bring it out front just like we did on the first problem, so now this is just going to be a coefficient, so we could pull coefficients out front. So if we pull this 3 out front, then we would just have, instead of multiplying it out, I'll times 3, okay, and then we have what's left, which is sine of 3x over 3x as x approaches 0. Okay, what about this? What's that value? 1. Good. Really good. And then what do we have out front? Just 3/4 times 1. This just simplifies to 3/4.